are, you know, kind of inverses of each other. So the way I'm going to teach this is going to be slightly different than the way you learned it last year, I think, from what I've gathered from the classes earlier today. But when I teach logs, I like to, as much as possible, reinforce the translation from log language, which this is currently in, to exponential language. So on day one of introducing logs, when you learn how to transfer from log format to exponential, would be taking the base of 2, raising it to the other side, raising it to the 5th power, and it equals what's in the middle. So I would just translate this, 2 to the 5th equals 4x plus 1, and solve. Now it's what kind of equation did it just become? Linear. Subtract 1 from both sides, and divide by 4. So x equals 31/4. Okay? On a second example, same thing, except for we have to isolate. You always isolate the logs first. So subtract your 7 over. Divide by 3. And then again, translate. What is the base of the ln? E. So it would be the base of E raised to the other side equals x. Any questions? Okay. You could write it as 1 over the cubed root of e. Is that what you're thinking? Yeah, that's fine. I will sort of depend on what the multiple choice options are. So you did this a little bit differently last year, right? I think. Did you take whatever the base was, in this case a base of 2, and make 2 raised to this power and 2 raised to the 5th? And then that just canceled to give you 4x plus 1 equals 2 to the 5th? Did you do that? Yes. That's what your classmates have reported to me that you did last year, which is fine. Same thing. My method more capitalizes on the definition of logs. This method capitalizes on that shortcut and kind of the idea that as long as if your bases are equal, then your exponents have to be equal for the sake of being able to use the shortcut. The same thing would apply here. You guys almost definitely raised E on both sides to get rid of an ln. Is that fair? Okay? So there's that method or there's my method. They both capitalize on different concepts, but they're both equally as effective, so whatever you prefer. On this one here, what does your gut tell you to do first? Combine, condense the logs, exactly. You cannot, with multiple logs on one side of the equation, you can't do any of what we just were doing. So we have to condense this first. So subtraction of same common logs turns into what? Division. And then once you have that single log, you can translate 4 to the first power equals x plus 2 over x minus 1. What kind of an equation has this become? Rational. Variables in a denominator. First thing we got to do is get that out of the denominator. Most of you are going to cross multiply, which is fine. I'm going to distribute while I'm at it. 4x minus 4 equals x plus 2. Get x's all by themselves, so subtract x over. Add your 4 over. And x equals 2. The next example is different simply because we have logs on both sides. What's your instinct there? Andy? You could do that. So you would maybe subtract this one over, condense them. It would equal 0. And you could follow the translation. The base raised to the other side of 0 equals whatever's in the middle. You could. Andy, go ahead and do it that way. What other way could we do it? Other people remember from last year, Dakota? Right, condense what's over here. Leave this one alone. Condense the addition by multiplying. 3 times x plus 3 is going to become 3x plus 9. And now that you have a single log on the left and a single log on the right, we can now just cancel those logs. It's just like kind of like having a common base in exponentials. Once you get a common base, you can just cross it out. Since they're both log base 10, you have to assume that what you're taking the logs of must have to be equal. So 2x minus 1 equals 3x plus 9, and solve, you get x equals negative 10. Andy, did you finish your way? Did you get the same thing?
Yeah.
Which one's easier? What's up?
The line.
You think so? And it's up to you. You could get them all to the same side and kind of follow those rules. But if you want to keep just logs on the left, logs on the right, and condense them all into one, you can do that. That actually, though, I will say this. If this was something like this, and it had just a different random number there, I would have to move this log over and condense this one with this one on the left-hand side. Do you see why? Because the only way to do the single log on both sides is to just, if it's just a log of something equals log of something. If there's anything additional there, that's not going to allow the cross-off to happen. Okay? So on this one, I would have to subtract that over, condense the two log subtractions into a log division, and then follow my translation. Any questions on that? And the last one. They're all natural logs. So I can condense on the left. And I can condense on the right. And I can cross off the natural log. What kind of equation is this? Linear, quadratic, exponential. What is it? Radical, absolute value, rational. What are we dealing with? Where's the variable? All over the place. Most notably, Lauren, the variable is in the, good Matt, denominator. So this is a rational. We got to get, again, the variable out of the denominator. Most of you are going to cross multiply. I'm going to FOIL while I'm at it. And cross multiply the other. Now what kind of equation is it? Quadratic, so we get it equal to 0. I'm going to subtract everything over to the left. My x squareds are going to cancel, so now what kind of equation is it? Linear, so just get that all by itself. Okie doke. Any questions or comments on any of these on the front? That's too bad. I was going to give out multiple bonus points, but someone picked up on it. You should have a question or a comment on something on the front.
Well,
You should have. Hold on. All right, Brianna, go ahead. You can't take the log of a negative. So some of these answers, like it's not the fact that x is negative that's the problem, although often Yeah, it's the fact that when you plug it in, -1 minus 5 gives you -6, and the natural log of -6, we're going to call that an extraneous solution. Well, we got to go back and look at all of them now. -10, when I plug that back in, I get -21. Yep, so that's a problem. Anything else? Questions? Comments? What do you think? Dakota, you're debating something. I can see the wheels turning. What are we all debating? The majority of your classmates are debating the same thing. The second one, I knew it, because we're debating if that's okay or not because we see a negative sign. Is that okay? Yeah, this is still a positive number, but you all second guessed yourselves. Don't lie. Don't make Dakota feel bad because you all wondered. Okay, on the back, take a couple minutes to, and I'm going to randomly collect 5 of these.
No.
Oh, I'll make it random. You watch.
That means not random.
Mm-mm. I mean, normally I think I'm always randomly doing it, but maybe for some reason, like consciously gravitate towards people. This time it's going to be purely random. Oh, it is. You watch.
Yeah, I guess so.
Birthday man. Do you know what other famous person was born on your birthday?
George Washington.
Oh, that's what I was thinking of. There's a website where you can see.
You want it?
I love her, so that's what I was thinking of. We would be best friends if I knew her. So I don't have some compatible with people on that birthday must be. Me and J-Lo. Call me Rahel from the block. No, you guys don't know that song? Jenny from the block? Oh, Matt. Matt, you watch your tongue. Sing it, prove it. Hi, Matt. What do you want? Can you just give me the one-liner lyric? Come on, Matt. You said you knew it. Give me one line of lyric.
I'm concentrating on that.
Raise your hand if you're done with all 5. Okay, keep going. Yep. What were you doing? You look like you were still working on one of them.
Yeah, but I couldn't stop.
Are some of these like numbers from yesterday?
Yeah, some of those are mixed in. Some of these are exponential, some of these are log. It's kind of a mixture. This is my random way of... Are you kidding? That one? Oh, that's okay. We're not, we're going to one thing on the paper. Different one? That's what you get for having a November, December, or January birthday.
My birthday's not even.
Those are the next 5, well, other than Brandon, but we had to point out that I missed his birthday the other day. Happy belated birthday, Brandon. Everybody else is coming up next.
What if I told you my birthday was 12? Let me put it in the process.
Let's say that stinks for you because I still got your paper. Okay. Numero uno. Thoughts on this? Anybody have any issues? See anything wrong with this? Dakota? So when you multiply common bases, you should multiply their exponents as opposed to adding them? Don't be mean to her. You're going to discourage her from speaking up, but you do know this is x to the 8. So when in doubt and you kind of can't remember a property because it's a little bit diluted, go back to a basic and remind yourself that it is addition, so x plus 2 plus x is 2x plus 2. Anything else? That's how we learn, Dakota. That's good stuff. Okay, that's correct. So they multiplied common bases, added the exponents, then they took the log base 3 of both sides. Log base 3 of 81 was 4, so they used that log base method, and then they got x all by itself. Good? Whose was that? Numero 2. They got the absolute value all by itself. They branched it off because of the absolute value into log of x equals 2, log of x equals negative 2. And they used their base of 10 raised to the other side equals x. And their 10 raised to the other side equals x. And they got 2 answers. Perfect. Whose was that? Here's number 3. Log base 5 on both sides cancels this. X squared equals log base 5 of 50. Any questions or comments on this? Luke. Correct. Anytime you take the square root of both sides, plus or minus. I didn't pick it randomly though. So Brianna would be upset if I did that. Okay. Fine, Luke. I'll give you a point. I kind of agree. I just don't have time to slow down to randomly pick, but since Brianna's not going to be a, well, that's not fair kind of person, then that's nice of her. Okay, moving on. Number 4. We condensed the natural logs on the left, turning subtraction into division, and raised e to both sides. Cross multiplied or multiplied that x squared plus 5x out of the denominator. It became a quadratic. Solved the quadratic. Any issues, comments, concerns on that one? I saw a hand across the room. Rachel? Why not? No, you're right. Well, you didn't plug it in wrong, but you're not supposed to have a calculator. But you're still supposed to know that that will give you, like, negative 5 minus something, who cares what, is still going to be a negative number divided by 2, which is still going to be a negative number. When you check that, you can't take the natural log of a negative number. But you're right. Good job. And the last one, they changed the 9 to 3 squared to the 2x power, which became 3 to the 4x. They dropped their 3's. They set their exponents equal to each other. Solved a quadratic. Any concerns? Dakota. Whose was this one? She said x equals negative 2 is extraneous. Why? We're not taking a log of anything. What doesn't check out? It does. This will be 3 to the negative 8th power, and this will be 9 to the negative 4, which are the same thing, because this is 3 squared to the negative 4.
I don't know why.
Because one's got a base of 9, the other's got a base of 3.
I'm just giving up.